Okay, so what I've implemented, if you've been familiar with my previous demos, I have on this website called ObservableHQ. They allow you to host JavaScript notebooks, and I've got a set of notebooks here with various. What they do is they all talk to a server I run, and when you run the notebook, it spins up on demand a local net with a bunch of Docker images, which spin up a couple of Lotus nodes, and they bootstrap a version of Filecoin from scratch, running a branch with the FVM and EVM support. So before I had the first demo here, the Hello World demo, was using the native actors written in Rust. So this is the custom actor written in Rust, which is quite verbose. But now that the latest version of Lotus pre-release has EVM support, so I wanted to do a version with a smart contract written in Solidity. So if you, for the Talc release, you can follow this issue here, and you can see there's an example smart contract in Solidity and instructions on what you can do with it, with a very, very, very simple example. And so I'm going to show you that running in a web page here. So the first time you go to this, if nobody has been running it, it takes a little bit for the Docker images to spin up and start running. And once they're running, you have the smart contract here. You can modify it if you want. Here, I'm going to just modify it just so that you can see that something actually changed. So I changed the initial coin balance for this ERC style token. Used to be 10,000, now it's 10,001. So I'm going to click this button here in step 2, and it's going to send that code over to my server. So I just have to click it twice. I'm not sure why. And it compiles it. It's really quick. It's like under a second. So, and what it does is it calls a little web API, and it sends bytes back. And this is actual bytes here, if you expand that. And then you can see here, it's actually spun up this Docker images, and you can see this height should be increasing. So it went from 122 to 123. So that means blocks are being generated. And so if that's good, so I can just click on this button, and it's just as opposed to the native actors, which had 2 steps where you had to install the actor code and then instantiate it. With the EVM actors, there's already a system actor with the virtual machine bytecode. So at the command line, you instead you call Lotus chain create EVM actor. So you can skip the install step, and it just shoots the bytecode across. So I've copied the JSON RPC call, and so this is essentially the equivalent to instantiating the actor with the native actors, and you get your ID address. So it's now on my local net, and I can call it. And in the example here, they give you two examples that you can do to confirm that it's working. So the first call is Lotus chain invoke EVM actor. You give it the address. This is just sort of a hard-coded number, which I assume is the method on the instance. And apparently this is the owner address. So if I invoke it, it sent a message to the actor. Takes 10 seconds for it to be included in a block, so we have to wait for that. And there, so it executed it, and you can see the number come back. So in this one, it expects 2710, but that's a hex number, so that's actually 10,000. The same as this line up here, except we added 1 to it. So we can actually see that it's actually running our modified code because we do this much. And then, we can try the non-owner one. I'm just guessing that it's calling the get balance method, but I don't really know. You know, that's funny. That one actually broke. Okay, I think when I clicked on here, it actually I have to load it again. Anyways, so that's what you can do with it. So what do I plan to do on with this one next? Obviously, there's going to be a new release coming out fairly soon, so I'll upgrade this to match it up with the latest release. I also, this is working against the localnet now. There's a new Glyph API node coming up, so I'd like to have a little toggle somewhere so you can choose between running against the local net or running against the live testnet. Of course, to run across this testnet, I'm going to need to enable people to have some funds in a wallet so they can actually fund installing on the live testnet. So I'll have to make a little faucet for that. So I've got lots of little things to tinker with, and I also want to experiment with some of the native things like the Polyphene SDK, high-level SDK for Rust actors, the active script, and the TinyGo actors as well. So that's where I'm at right now. So.